on the math model in STEM education. Again, I think he's very familiar with the drill, so I'm not going to say anything, but enjoy.
Assalamu alaikum. My name is Hisham Hanafi. I am a math teacher in Higher College of Technology, Sharjah Colleges. Today, inshallah, we will talk about math model and STEM education. How can we teach math integrated with science, technology, and engineering in the classroom? So to talk about this topic, first, we need to know what is STEM. So I will start with introduction. What is STEM and why we need STEM nowadays? Why all the world try to apply STEM in their schools and universities? This is the introduction. Then I will move to the next step. How to integrate STEM inside the classroom. What is the best strategy to teach math using science, technology, and engineering inside the classroom? To talk about this point, as we will see, STEM is the integration between science, technology, engineering, and mathematics. So we need to talk about what is the cross-disciplinary curriculum. And then we will talk about the cross-disciplinary curriculum and STEM. What is the relation between cross-disciplinary curriculum and STEM? Then, when I choose a teaching strategy, this strategy should be aligned with the objectives or the goals of my college. I can't use another teaching strategy that's not aligned with our goals. So that's why we will talk about HCT goals. And then we will identify what is the best strategy to integrate or to teach math integrated with science and technology and engineering. After that, we identified the project-based learning as the best strategy to teach math integrated with science, technology, and engineering. Then we need to know what is the project-based learning, what is the relation between project-based learning and STEM, or another word, what is STEM project-based learning? Then we'll see what is the relation between STEM project-based learning and creative thinking skills. Finally, I'll show you what is the suggested approach to be used inside the classroom, how we identify the project, how I create the project, how I run the classroom. Then I'll show you a practical example on a math lesson to be integrated with science, technology, and engineering. Then the conclusion will include the importance and the contribution of integrating math with science and technology and engineering in UAE. Let's start with the first part. What is STEM? According to Florida Department of Education, STEM education is the international integration of science, technology, engineering, and mathematics, and their associated practices to create student-centered learning environment. And we can see STEM in different type of integration, different level of integration. So, science class without any other STEM components, it's considered to be STEM, but STEM 1.0. The full integration between science, technology, engineering, and mathematics, it's also STEM. So we have 4 types of STEM. STEM 1.0, when you teach each of the STEM disciplines separated. Science alone, math alone, technology alone, engineering alone. It's STEM 1.0. If you integrate 2 disciplines together, it's STEM 2.0. Give me an example. In science class, if the teacher teaches the lesson and asks students to, a science class use computers to research a problem to develop a presentation. So he teaches science and he uses a computer to present the solution of the problem. It's technology, so this is the integration between science and technology. So you can integrate 2 disciplines together. This is STEM 2.0. STEM 3.0, when you integrate 3 disciplines together, like science, technology, and engineering, science, engineering, and math. Give me an example. Science class use a computer to research a problem, to develop a presentation. This is science and technology. And then groups use engineering process to develop a solution for the problem. So this is the integration between science, technology, and engineering. Integration between only 3 disciplines, so this is STEM 3.0. The full integration between the 4 disciplines called STEM 4.0. The full integration between science, technology, engineering, and mathematics. An example, this is my research by the way. A math class use simulation software to simulate basic electrical circuits. Math class, this is mathematics. Simulation software, this is the integration of technology. To simulate a basic electrical circuit, this is the science. Then students apply this information to create engineering project. So students will use the engineering design. So this is the integration between the four disciplines. Now, why we need STEM? Why? Look at this device. This device costs around $700. Why the actual cost for manufacturing this device not exceeds $100? Where are the other $600? This is for the information inside this device. But what is the information or what is the domains or the sciences included to create this device? It's math, science, engineering, and technology. That's why all the world go to STEM, because of what? The knowledge economy. United Kingdom, the United Kingdom government sees STEM education as a milestone in any successful economy. Therefore, much attention has been paid to innovation and enhancement of competencies in science, technology, engineering, and mathematics STEM. By the same way, in UAE, in October 19, 2014, Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE, launched the new strategy to make the UAE one of the world's most innovative nations within 7 years. It means by 2021. That's why the KPIs until 2021. And he identified 4 tracks to apply his strategy. The 4th track, this is the most important one for us, the 4th track will qualify individuals with highly innovative skills by concentrating on science, technology, engineering, and mathematics, including the creation of educational material for schools and universities. So we have 2 things here. We need to concentrate on math, science, technology, and engineering, which is STEM education, to what? To develop the creativity, to develop creative thinking skills. How can we use it with teaching math? This is what I will say now. Now let's move to the next step. Now we know what is STEM and why we need STEM. The next step, how to integrate STEM inside the classroom, inside math classroom specifically. What is the best strategy to teach STEM or to integrate STEM? To talk about the best strategy, as we know, STEM is the integration between 4 disciplines. So we need to talk first about the cross-disciplinary curriculum. We have 3 types of cross-disciplinary curriculum: multidisciplinary, interdisciplinary, and transdisciplinary. What the difference between the 3 types? Multidisciplinary, you will teach each discipline alone, separated. Interdisciplinary, this is the integration between the disciplines. What does it mean, integration? I'm teaching math, I will search for the common area between math and science to apply the math concepts. This is the integration. So this is the interdisciplinary curriculum. The last one, transdisciplinary, you will merge all the disciplines together to create one curriculum. And I think this type of curriculum, which is a transdisciplinary, applicable only in the primary schools. It's not applicable in higher education or secondary or even middle school, because the depth of the subjects becomes bigger and bigger. So we can't merge the subject together to create one curriculum. We can do it with the lower level of education in the primary schools. Now, what is the relation between cross-disciplinary and STEM? We said we have 4 types of STEM. STEM 1.0, 2.0, 3.0, and 4. STEM 1.0, this reflects multidisciplinary curriculum because we teach each discipline separated, right? STEM 2.0, 3.0, and 4.0, when you integrate 2 or more disciplines, this is the interdisciplinary curriculum. Also, you can merge the 4 disciplines together to create one curriculum in primary school or in lower level in education to create transdisciplinary curriculum, to create one curriculum. And we can see it in the primary schools when the students learn by projects. Our project in level 1, for example, is Journey to the Space. And during this project, students will learn math, science, technology, engineering, everything in one project. This is transdisciplinary. Now, to select, as I said, a teaching strategy, this teaching strategy should be aligned with our goals. But what is HCT? HCT is an applied higher education institution in the United Arab Emirates. It aims to produce knowledgeable, innovative, and skilled Emirati graduates to support the nation in pursuit of excellence. And the goals of HCT focus on what? Focus on using applied education. Applied education, the math is very abstract subject. How can I convert it to applied subject? How? So if I can use the math concepts to create projects, math becomes applied subject. So, in my opinion, project-based learning in teaching math is one of the good strategies or the best strategies to teach math integrated with the other disciplines. A lot of researches support this idea. Around four researchers said that consider project-based learning is the best strategy to integrate STEM in the class, inside the classroom. So now we identify, we know what is the STEM, what the type of STEM, and what is the best strategy to integrate STEM inside the classroom. Now let's move to the next step. What is project-based learning? We will use project-based learning to integrate math, to teach math integrated with the other disciplines. So what is the project-based learning? What is the relation between project-based learning and STEM? Or in another word, what is STEM project-based learning? What is the definition of STEM project-based learning? Then, what is the relation between STEM project-based learning and creative thinking skills? Remember the UAE vision? They need to be one of the most innovative countries, so we need to develop creative thinking skills. So what is the relation between STEM project-based learning and creative thinking skills? As we know, any teaching strategy should reflect an educational theory. The educational theory behind project-based learning is the constructivism, where students construct their own understanding and knowledge of the world through experiments, experience, and reflection. And there are three types of teaching strategies from constructivism: inquiry-based learning, problem-based learning, and project-based learning. Look at the definition of the project-based learning. Students work in groups, seeking multiple sources of information and creating authentic product. So students can use many disciplines, math, science, technology, and to create an authentic project, it's engineering design. So through project-based learning, it's really the best strategy to integrate the four disciplines of STEM. What is the relation between project-based learning and STEM? I am a math teacher. I will teach a topic of math. What will I do? First, I will search for a common area between math and science. Why science? Because science is the applied math. I will search for a certain topic in science aligned with my math topic. So it will be this area, the intersection between math and science, this area. The next step, I will try to find a technology tool to teach the science application. So the circle will be smaller. Look here, this is the intersection between math, science, and technology. Then I will search for an engineering project to apply the science and math concepts. So the project-based learning, the STEM project-based learning will be in this area, the small area here. This is the STEM project-based learning. The area of intersection between the four domains, between math, science, engineering, and technology. Now, what is the relation between STEM project-based learning and creative thinking skills? As we said, our main educational theory is the constructivism. One of the teaching strategies of the constructivism is the project-based learning, and we will use this strategy to integrate STEM. Project-based learning requires, or while teaching project-based learning, we will have three types of learning happen in the classroom: cognitive learning, content learning, and collaborative learning. Cognitive learning like what? Critical thinking, creative thinking, decision making, problem solving. What is the content learning? The content itself, the math content, the math topic. And the integration are the connection between math and science, the connection between math and engineering. This is the content learning. And the collaborative learning, the collaboration, self-direction, and communication. So it's clear, STEM project-based learning will develop what? Creative thinking skills, which is our goal, to develop creativity and creative thinking skills. Now, we talked about what is STEM, why STEM, and how to select what is the best strategy to integrate STEM inside the classroom. And then we learned what is the project-based learning and the relation between project-based learning and creative thinking skills. Now, as a teacher, how I will apply this strategy in the classroom. So I will talk about 2 points in this part, the suggested approach and practical example. I'll show you a practical example, math topic, and I will teach it by using science, technology, and engineering. I will talk about this point quickly because, okay, this is a suggested strategy. I will use Deming the model. Deming is an American statistician, and they call him the father of quality. He developed Deming model, Deming cycle for continuous improvement. Deming model contains 4 steps: plan, do, check, act. During the plan, I will develop my project and create the required material. And next step, do, I will apply the project inside the classroom. Then check, I will use the assessment tools. Then I will take the appropriate action based on the student's result. The most important, the 4th step is post-project activity. This is the most important part where I will write what works and what doesn't work. What are the problems to enhance the project each time I apply. Now let's move to the most important part in my presentation, which is how to teach math using science, technology, engineering. Before I start with this part, I will teach a complex number. Before we start with this part, I want to give you a brief information about what is the complex number. When we try to solve this type of equations, x squared minus 9 equals 0. How to solve it? Oh, it's easy. Move 9 to the next side and change its sign. So x squared equal 9. How can we find the value of x? Take the square root of the 2 parts. So x equal positive or negative square root of 9. It means x equal positive or negative 3. Easy. But when we try to solve this equation, x squared plus 9 equals 0. Okay, by the same way. Move 9 to the next side. So x squared equal negative 9. How to find the value of x? Take the square root of the 2 sides. So x equal positive or negative square root of negative 9. Stop. Why stop? We don't know what is the square root of negative 9. Why we don't know it? Because the concept of the square root is what? You try to find a number multiplied by itself to get this number. So 3 times 3 equal 9. Negative 3 times negative 3 equal 9. So that's why square root of 9 equals positive or negative 3. But what is the square root of negative 9? We don't have one value multiplied by itself to get negative 9. So what is the solution? This is the time to get a new set of numbers. This set of numbers called imaginary numbers, where we separate negative 1 from 9. So x equal positive or negative square root of negative 1 times square root of 9. Square root of 9 means 3, and square root of negative 1 we refer it by using I or J. Some math books refer to it by using I and some by using J. So the solution here equal positive or negative 3i. This number called imaginary number. Okay, what is the complex number? The complex number contains the 2 types of numbers, real number and imaginary number. Like what? 3 plus 2j or 2i. This number called complex numbers because this is formed from 2 parts of number. 3 real number and 2i is imaginary number. That's why we call this number complex number. One more concept about the conjugate number. The conjugate number of the complex number is the same number but different sign. So 3 plus 2i, what is its conjugate number? It's 3 minus 2i. This is the meaning of complex number. Now let's move to our project. How to teach it inside the classroom? This program called multi-sim program or multi-sim simulation program. I construct basic electrical circuits. Okay. Sorry. Okay. Any loads in the circuits. Any loads in the circuit measured by the complex number. Okay. Type. How can we teach the operation of complex number by using this electrical circuits? We get the maximum power of the electrical circuit if the total of the loads is a real number. It means that imaginary part will be cancelled. So what we do to teach, for example, adding and subtracting the complex number, I'll give the student this example and I'll ask him to get the maximum power of the circuit. Okay, students will add these two loads and then he will change the values of the third load by using the conjugate value. For example, if the total load of these two loads is 2 plus 2j, he will change the value of the third load to be what? 2 minus 2j. By this way, the imaginary part will be cancelled, so the total loads will be a real value, so we'll get the maximum power. Now, how can we know if it is the maximum power or not? I attach it with the circuit wattmeter. This device show me what is the maximum power. If we double click on the wattmeter, you will get what? Power factor 0.97. We get the maximum power if the power factor is 1. So it means that the power from this circuit is not the maximum power. So the third load is not the conjugate value of the sum of the other two loads. One more comment. To teach add and subtract a complex number, we will connect the loads in series. To teach multiply and divide the complex number, we will connect the loads by using parallel. Because the maximum, the total load, if the loads connected in parallel, 1 over R total equal 1 over R1 plus 1 over R2. To find the total, we need to multiply and divide the complex number. The engineering project.
I think maybe people might have more questions.
I need only one minute. The engineering project related to this topic is what? Controlling the level of light. When you come to any smart house, you have a button, you can move, you can increase the lighting level, right? This is a direct application of the complex number. Because, as we said, we will get the maximum power of the circuit if we cancel the imaginary part. So this button, called potentiometer, when we move it, it will change the types, the values of the complex number to be cancelled. Once it's all the imaginary part cancelled, we will get the maximum power. It means the highest level of light. I will run the simulation to show you this the project. Look here. If it's 0, the power is very low, so the light is not working. Once we increase the potentiometer or change the values of the complex number, until we cancel the imaginary part, the light becomes to the maximum. Look here, when we change the value here, it becomes better. Look here, the graph bar show the current. And when we get the maximum, 100%, the bar to the maximum and the light to the maximum. This is the engineering application for the complex number. So inside the classroom, I will use the simulation software to teach the project, and in the engineering lab, the students will use the engineering design to create this project in the practical. Thank you, and I'm sorry for Thank you.
Mr. Hisham. I know that it's a very interesting topic that you discussed there. So we'll just give you one question, maybe. I don't know, just not to disadvantage the other speaker, so if there's any questions, no?
That's okay.
It's okay. Any questions on the session?
One question I love everything you did, and my question is, do you find you can still get through the math syllabus that you have to cover?
Yes. Look here. This is the pre-calculus course, and this is the learning outcomes. We have 5 learning outcomes. Complex number is one of these learning outcomes. I will create one project called Smart House, and inside the Smart House, I will put application for each learning outcome. For the complex number, the controlling the light level. This is a complex number and this one, trigonometry. Regarding to the exponential function, I will put what the timer. When you click on the button, the light will open for 3 minutes and then switch off automatically. This is direct application for the exponential function. For the polynomials, we'll put the thermostat. Once the temperature, for example, becomes 25, it will open directly the AC. It's direct application for the polynomial.
If I could just follow on, because again, I love everything you've done. I think it's definitely a great way to teach it. Do you find you can cover those topics in the depth that the students end up being tested on?
Yes.
That's wonderful.
Thank you.
Okay. Thank you so much.
Thank you.
Thank
you.
Okay. So,
Sorry for the delay.
well, we've used up a little bit of time, but just for people to maybe decide whether they want to stay or move.
I have this picture of like guys working in their garages with startups, you know, doing all of this stuff. And something like Bill Gates or Steve Wozniak starting something up. All right, now I'm not very tech savvy. I'm like old school. Okay. Good, because I want to use